We've said that we can make copies of read-only and read-write non-conflicting variables in any task that needs them. But we can also make copies of read-write conflicting variables under certain conditions. And that's why we want to consider the issue of privatization. What's the advantage of privatization? Well, think about the disadvantages of read-write conflicting variables. I said that we had to access them remotely, and we had to worry about concurrent access. With privatization, we don't have any read-write conflicts, so we can let tasks run in parallel and not have to worry about who else is reading or writing the variable. Of the three kinds of variables in the tables above, which kind does it make sense to privatize? Well, we said we could make copies of any read-only variables. We didn't have to worry about copies of them. And read-write non-conflicting, well, it's accessed by only one task, so we don't need to make copies of it. Therefore, it's read-write conflicting variables that we're interested in. Under what conditions is a read-write conflicting variable privatizable? Well, there are two of them. First of all, if the variable is always defined, which means written, in program order by a task before being read by the same task. So if a task always writes the value of a variable before it reads it, we know we don't have to worry about any update that was made by any task before that, because we're never going to read that value. The second case is if the value of that variable in different parallel tasks is known ahead of time, so we can make private copies with those values that the different tasks will have for the variable. And this will be case 2. The other one's case 1. When a variable is privatized, one private copy is made for each thread. And I say not each task because remember that tasks can be combined into a thread. It's just that you run one task as part of a thread and then the thread goes on to another task. So it's all sequential. And that allows us to use one copy of the variable for the whole thread, not just each individual task in the thread. The result of privatization turns a read-write conflicting variable into a read-write non-conflicting variable. So let's look at the example that we had before. Let's look at example 1 and see which variables are privatizable. Let's take the case in example 1 where each for-I iteration was a separate task. And in this case, which of the read-write conflicting variables are privatizable? Well, note that the read-write conflicting variables were I and j. Which of them would be privatizable? Can we create a separate copy of I for each iteration? Can we create a separate copy of j for each iteration? Well, yes, we can. Which case does each variable fall into? Well, let's think about I. If we're doing a for-I loop, we know what the value of I is ahead of time. It just gets set to something and stays that way for the whole loop until it gets to the very end, in which case it's incremented next value. So that's case 2. A value in the different parallel tasks is known ahead of time, allowing the private copies to be initialized to the different values of I, in this case, in the different tasks. Now what about j? j starts out by being initialized to 1 at the beginning of the loop, and then it's accessed. But no task will access j before it initializes it at the beginning of its j loop, and thus it's case 1, a variable that's always defined or written in program order by a task before being read by the same task. One way of thinking about privatized variables is as arrays, where there's one array element for each process, and it's indexed by process ID. So each process has its own copy of the variable, and we don't need to worry about the processes stepping on each other's toes, so we don't need to control access to those variables. Now let's take example 2. Here we have the same situation, but parallel tasks, one for each for-j loop iteration. In this case, our read-write conflicting variables were a and j. What about j? Is it privatizable? Yes, it is. It's the same situation as I was before, case 2, where its value is known ahead of time. The other read-write conflicting variable is a, and we can't privatize the whole array because the other threads need to update values at the same time they're being used by this thread. Now look at example 2 and answer the question in the quiz.